began to question now the more basic foundational astronomical, cosmological foundations of the Greek tradition.
And question they did. What's absolutely striking about the writings of Islamic scholars by the 9th century is the increasing use of the word shukuk, which in English means doubts.
They showed that it's sometimes necessary to doubt an idea that everyone around you believes unquestioningly. Islamic doubting of Greek astronomy began the slow process of undermining the notion that the Earth is at the center of the universe. To doubt takes great courage and imagination. But if the great dialogue between Islamic and European astronomers shows anything, it's that doubt, or shukuk, is the engine that drives science forward.
One of the first great shukuk scientists was called Ibn al-Haytham. He was born in the Iraqi city of Basra in 965 AD and was among the first to argue passionately that scientific ideas are only valid if they're mathematically consistent and reflect reality. And when he applied his fierce, rigorous intelligence to Greek astronomy, he immediately spotted that there was a fundamental contradiction at its heart. On the one hand, Greek cosmology argued that everything in the heavens revolves around the Earth. On the other hand, Ptolemy, in his Almagest, argued that if you want to mathematically predict how the sun and planets move, you have to pretend that they go around an arbitrary point in space, the so-called equant. This is clearly a contradiction. The heavens can't both go around the Earth and not go around it at the same time. Ibn al-Haytham hated this nonsensical contradiction. In the early 11th century, he wrote a paper, Al-Shukuk ala Ptolemaios, or Doubts on Ptolemy. In it, he writes with barely contained frustration, Ptolemy assumes an arrangement that cannot exist.
Ibn al-Haytham says that is a total absurdity. We cannot accept that, and furthermore, he says, it's not a slip of a tongue. Ptolemy knew that it was an absurdity, and he shows us where Ptolemy himself was embarrassed by having to introduce it. So he says there is a fundamental reasoning problem, meaning that the Greeks knew that Ptolemy knew that he was making a mistake, but he knew he couldn't do any better, and hence now the challenge is to do one notch better, and hence to be able to fix this. That, in my explanation, begins to be the program of research for all astronomers to come.
In order to achieve that project, you had to be convinced that it was possible to make high precision mathematical models of the way in which planets and stars move that would really capture how they are in the heavens.
Ibn al-Haytham, in effect, laid down the challenge for all astronomers who followed, which was to come up with an explanation for how the heavens move that is both mathematically consistent and agrees with what we observe. The final answer to this would come from faraway Europe with Copernicus and others. But the next and crucial instead of a sphere rotating around an arbitrary point in space, Al-Tusi devised a series of two nested circles which rotate around each other in such a way that they eliminate the equant. The nested circles became known as a Tusi couple. This is the mathematical system that finds its way into Copernicus's work some 300 years later. Having found a solution to the equant problem, Al-Tusi now wanted to complete the task Ibn al-Haytham had started 200 years earlier, to find a consistent mathematical description of the movement of the celestial bodies. But to do that, he needed better data, which meant bigger and better equipment than he was ever going to find here at Alamut. And then something happened which changed El-Tusi's life forever. The Mongols. Streaming in from the east, an army of Mongols led by Hulagu Khan marched into Iran, crushing everything before them. By 1255, they had reached the foothills of Alamut, intent on its destruction. Then, in a brilliant piece of diplomacy, El-Tusi managed to both save his own skin and satisfy his scientific ambition. He visited the Mongol leader and played on his deep astrological superstition, convincing him he could tell the future if only he had new equipment. El-Tusi persuaded the Khan to make him his head scientist and to build him just a few hundred miles away, perched on a hilltop where the air was clear, the largest observatory the world had ever seen. This is all that remains of the Maraga Observatory. The main instrument is hidden under this protective dome. El-Tusi's new astronomical center was based around a single large building. Inside was an enormous metal arc, an armillary arm, 10 meters across. On its circumference were marked angles in degrees and minutes. The scientists would line up the celestial object under study with a central point on the arc, and then make a reading from the markings on the arc, giving them the definitive, accurate position of the object in the sky. The building was also surrounded by smaller astronomical equipment, libraries, offices, and accommodation. The observatory even had its own dedicated mosque.
I suppose it is a little disappointing that there's not that much left of the place now. So you really have to imagine what it must have been like back in its heyday. After all, what El-Tusi built here was nothing less than the world's greatest observatory for 300 years. And like any modern-day international research institute, he brought together the world's greatest astronomers from as far away as Morocco and even China. I mean, it must have been a really great, buzzing atmosphere to work here.
With his new observatory and world-class team, El-Tusi was now ready to fulfill Ibn al-Haytham's dream, to try to make Ptolemy's model scientifically rigorous. First, they attacked the mathematics. As well as the Tusi couple, they invented other systems of planetary movement. And with these new systems, they were able to calculate mathematically consistent models for many of the celestial bodies. Mercury, Venus, Mars, Jupiter, Saturn, and the Sun and Moon.
El-Tusi and the astronomers he brought together created what became known as the Maraga Revolution, which was a complete paradigm shift in astronomy, overthrowing the old Ptolemaic view.
What Islamic scholars and astronomers like Al-Tusi do is to organize and make sense of mathematical astronomy at a level of unprecedented accuracy, using instruments more precise than had been built before, over longer timescales, with predictions of the positions of planets and stars that no one had previously reached. That at Maraga or at Alamut, we see, I think, genuine revolutions in the level, scale, and intensity of mathematical astronomy.